So normally we would use graphite electrodes. Two reasons. First reason is that graphite is inert. That means it's unreactive. Second reason is it is a good conductor of electricity. Remembering graphite based from carbon wants to make 4 bonds and graphite makes 3. Therefore it has delocalized electrons which are free to move. Okay, from this experiment, give the reactions which take place. So if I look at what I've got going on here, I can see I've got copper sulfate in solution, and then my electrodes here are both made from copper. So they're going to take part in the reaction. Graphite don't take part, copper do take part. So this kind of doesn't really matter other than to know that there are going to be copper ions in solution. So where are those copper ions going to go? They're going to go to the cathode. So at the cathode, I'm going to have copper ions arriving. What's going to happen to those is they are going to pick up 2 electrons to form copper. That is reduction taking place. And because the anode is made from copper, this is going to break down to replace the copper ions. So my copper anode is going to break down to form copper ions. And how does it do that? By releasing 2 electrons, and therefore that's oxidation. What's going to happen in terms of ions to the mass? Well, my cathode, my mass will increase. Why? Because I've got new copper formed. New copper is being made there. Remember, look, here you can see it. There's the cathode, new copper being made. And what would happen to the anode? The anode mass will decrease. Why? Because ions are being formed. So the anode is breaking down to form the ions, therefore the mass will drop. How can I increase the amount of copper? So basically saying how can I increase the rate of electrolysis? What I can do is I can increase the current or the voltage in the DC power supply. I can also increase the concentration of the copper sulfate. I could let it run for longer, so increase the time. I could leave it running for longer, and that therefore more time for electrolysis, therefore more copper is going to be deposited. Other things I can do is reduce distance between electrodes. We could do that. I could increase the surface area of the electrodes. If I can make those have more contact with the electrolyte, then electrolysis is going to happen faster. Any 3 of those is going to be good for your answer. And then this one's a good question. How would it change if I swap these for graphite? So I take off the copper and swap them for graphite. Right, this is very important because my electrolyte now is copper sulfate AQ. My graphite do not take part, so that's going to change. I need to know which ions are in here. So I'm going to have copper ions, Cu2+, and I'm going to have sulfate ions. The fact it's AQ means that water is involved. And when I've got water involved, I'm going to release H plus and OH minus. So I've got 2 cations. Which one's going to go first? Well, the cathode, the rule is, let's get my rubber. The rule is that the least reactive is reduced first. So of these 2, that's going to be copper, Cu2+. It's going to pick up 2 electrons and it's going to form copper. That's the same reaction, notice, that we had earlier on with a copper electrode. The anode is going to be different because 2 anions, the rule here is that the simplest is going to be oxidized first. So the simplest of these 2 is the hydroxide. Hydroxide equation, this is the one that students always forget. If you don't know it, go and learn it. You have to know this. It's dead cert to be on your test. It's worth marks. Go and learn that equation. And remember that this equation produces oxygen, therefore I see bubbles of gas. I can collect the gas, glowing splint, and it will relight the splint to prove it is oxygen. You need to know that information.